Salam, peace be upon you. Imagine you are walking at night with a small lantern. The lantern is not a map. It does not tell you what the whole world is. It only tells you what is true along your path, step by step. Now imagine you walk a complete loop. You leave your starting point, you wander, you return. When you arrive back where you began, you look at the lantern. It has not changed its shape, but it carries something you cannot deny, a memory of the loop you just completed. Not a story, not an opinion, a token. That is the feeling we are naming today, holonomy. In part 18, we met the first whisper of discreteness inside a continuous language. We learned that closure forces exactness. When a loop is truly closed and the domain is clean, the facelift can only come back to itself up to full turns of the circle. That is why the loop integral of the phase change is forced into multiples of a full cycle. The result looks like a number, an integer, because closure has no room for almost. Holonomy is the next step, and it is deeper than just counting turns. Holonomy is winding rewritten in the native group form. It is what the loop returns with when it comes back home. So let's hold the story of the lantern, but now we put it into the strict PS0 language. We are still inside the same alphabet. We have phi, a map from X to the circle S1. We have local lifts, phi tilde, taking values in the real numbers on patches where lifting is legal. We have A, defined as d phi tilde, the derivative word. And we have clean domains D, where derivatives and jets are lawful. Nothing else. No metric, no connection, no imported forces, no measurement talk, no particles, no fields as substance. Only language. Now, the holonomy token is defined like this. Say it slowly because it matters. H of gamma is defined as the exponential of I times the closed loop integral of d phi tilde along gamma. Written in symbols, it is H of gamma is equals expand of I invite gamma d phi tilde element of u dot 1. For audio, hear it as H of gamma equals e to the power I times the loop integral around gamma of d phi tilde. And H of gamma is an element of U1, the unit circle group. That single line is the holonomy token. It packages the loop memory in the natural place, on the circle. Because phi lives on the circle. Because phase is cyclic. Because when you return, the only honest memory you can carry without inventing new primitives is a circle-valued token. If winding was the integer that closure forced, holonomy is the circle-valued record of closure. It is the phase memory of the loop. And now we need to make that completely simple. Think of a clock face. Remember, we are not adding time as a primitive. The clock face is just a picture. The circle is our only native shape in phi language. On a clock face, 12 o'clock and 12 o'clock are the same point. But you can arrive at 12 o'clock having made 0 full turns, or 1 full turn, or 2 full turns. The clock face cannot tell you the number of turns. It only tells you where you are on the circle right now. That is exactly what holonomy does. It forgets how many full turns you made in the lift. It remembers the final point on the circle after wrapping everything back into U1. So in a clean, defect-free situation, where the loop integral is 2 pi times an integer, the holonomy becomes exp I times 2 pi times n, which is 1 on the circle. E to the I 2 pi n equals 1. That might sound at first like holonomy is trivial, like it always returns the same token, like the lantern always shows the same color. But that is only true if we are speaking about the special case where the loop integral is forced to be an exact multiple of a full circle on a smooth lift-valid domain with no additional global structure being sensed. Holonomy becomes powerful because it is the native way to talk about loop memory even when the integral is not packaged merely as an integer of full turns. It is the language's way of staying honest. Here is the key idea you can hold. Winding is how many full circles, holonomy is what point on the circle. Winding is a count, holonomy is a token. And tokens compose, tokens multiply, tokens behave like a group. That is why holonomy is written as an element of U1. If you want one concrete image, winding is how many times you wrapped a ribbon around the pole. Holonomy is the final alignment mark on the ribbon when you return to the start. Now let's anchor it to our tri-unity discipline, because that is non-negotiable. We have the tri-echo, omega, kappa, nu. Cadence, texture, transport. Not separate things, not independent primitives, just three inseparable readouts of the same A, where A equals d phi tilde. Holonomy is a global constraint on A. Since A is what gives rise to the three readouts, holonomy is also a global constraint on the tri-echo. Here is the simplest way to say it. If two loops have different holonomy, then the tri-echo cannot be globally the same across them when recomposed back into A. In other words, holonomy is a global signature of the same underlying tri-structure change. This is important because it protects us from a common cheat. People often try to talk as if they can change cadence without changing texture, or change transport without changing cadence, as if these are separate knobs. Holonomy is one of the ways the language prevents that cheating. A is one object. Holonomy is a constraint on A around closed loops. So if the constraint changes, the tri-echo must change as a welded whole somewhere. Now let's build intuition with examples, but we must stay PS0 clean. Examples can be metaphorical across scales, but we cannot import prohibited primitives as foundations. We can use them as pictures for the same grammar. Start with the simplest example, walking around a tree. You stand at a mark on the ground, you walk a complete circle around the tree, you return to the mark. The winding number tells you you went around once. That is the integer. Holonomy tells you, after compressing everything back onto the circle, what is the phase token of the loop? If the walk is truly closed and the domain is clean, the token is stable. You can wobble your path. You can make it wider or tighter. The token does not change unless you cross an obstruction. That word, obstruction, is crucial. In Holophase language, any surprising change in loop memory must be routed into domain typing, defect, boundary, cut, or degeneracy, not into a new primitive. That brings us naturally to the gates. But before we name them, feel the difference between a story and a token. A story says, I walked around the tree and it felt windy. A token says, this loop in this clean domain returns with holonomy h of gamma. The token is what survives redescription. Now we install the gates as living hygiene inside the story. First, the well-formedness gate. A holonomy sentence is only a sentence if the loop is valid. That means gamma must be closed. Gamma must lie entirely in the excised domain D. Gamma must have declared orientation. Why orientation? Because without orientation, you can't even tell the difference between clockwise and counterclockwise traversal. You cannot even assign a sign to winding, and holonomy depends on the directed integral. Orientation is part of meaning. So the WF gate sounds like this in plain language. If you want to speak holonomy, you must hand me a real loop, not a sketch. It must close. It must stay in the clean domain. And you must tell me which way you walked. That is not pedantry. That is what prevents fake claims. A loop that doesn't close cannot return with a token because it never returns. A loop that crosses outside D is not inside the derivative grammar. It is in the region where A and jets are undefined. So you cannot take the loop integral of d phi tilde as if nothing happened. That would be speaking illegal language. So closed loop inside D with declared orientation. Then holonomy exists. Second, the invariance gate. Holonomy must not change when we merely change descriptions. In pure phi language, the allowed redescription moves include phi goes to phi plus c, adding a constant phase shift. This is gate shift. And phi tilde can go to phi tilde plus 2 pi times an integer n because lifts differ by full turns. This is lift change. And we can change charts on overlaps because x is patched. The holonomy token must survive all of these. Why? Because holonomy is meant to be semantic. It is supposed to be what is the same regardless of notation. So in plain language, INV gate sounds like this. If your holonomy changes because you chose a different zero for phase, or because you counted your circle from a different branch of the lift, or because you used a different coordinate patch, then your holonomy was never meaning. It was bookkeeping. This is the heart of representation independence. It's like reading the same poem in two fonts. If the meaning changes because the fonts changed, you are not reading meaning. Holonomy is meaning only if it is stable under these changes. Third, the domain gate. Holonomy is undefined if the loop is not admissibly contained in D, unless we explicitly invoke defect typing later. This is the same honesty we installed in part 16. If the loop crosses sigma, a defect neighborhood, the lift might not exist there. If the loop crosses B, a boundary color, we might not be allowed to talk derivative language there. If the loop crosses a declared cut locus, we must account for it honestly. So the domain gate says, holonomy is not a magic spell you can cast anywhere. It is a token you can compute only where the language permits calculus. This is where holophase becomes a discipline rather than a vibe. Fourth, the non-encodability challenge. If someone says, I have discovered a new global primitive, the first question is, can you express it as holonomy, winding, charges, plus jet constraints? If you can, it is not new. It is a repackaging. If you cannot, then you must prove non-encodability. You must show it cannot be expressed within PS0 tokens, not just that you haven't found the expression. So NEC gate sounds like this. Before you add a new noun to reality, show me that the old nouns cannot say what you are saying. This gate is what keeps the ontology clean. Now, with the gates installed, we can deepen the meaning of holonomy without drifting into forbidden primitives. Holonomy is the native global grammar of phase memory. It is how the language lets the whole domain talk back to the local derivatives. Because jets are local. They tell you what happens near a point up to finite order. But topology is global. It tells you what happens when you walk a loop and return. Holonomy is the bridge token between local and global, built from A, but recording loop memory. Now let's bring in analogies across scales to make it stick. First, music. Think of a melody that begins on a note, travels through changes, and returns to the home note. The winding number is like counting how many full phrases you completed. But holonomy is the key fill you return with. The home note is the same, but you can return resolved or unresolved, bright or dark, stable or tense, depending on the path through the chords. Now, we have to be careful. We are not claiming music is phi. We are using it as a picture. The holonomy token is like that final angle of resolution. It lives on a circle because musical phase lives on a cyclic structure of return. Second, weaving. Imagine a carpet loom. You weave a thread around the warp and weft and bring it back to where you started. If you return with the thread aligned perfectly, the pattern continues seamlessly. If you return with a twist, the twist is not a new thread. It is a memory of how you traverse the loop in the weave. Holonomy is that twist token. It is not a new substance. It is a record of the loop. Third, biology. Think of a biochemical cycle. Something enters, transforms through steps, and returns to a starting form. What matters is not only that it returns, but what token it produced or what phase relationship it carries forward. In our language, holonomy is that return token on the circle. It is what remains after you wrap the accumulated change back into a cyclic value. Fourth, civilization. Consider a society that goes through a cycle: stability, crisis, reform, stability. Two societies can return to stability and yet carry different return tokens, different institutions, different norms. Again, we are not importing governance as a primitive, we are using it as a picture of loop memory. Holonomy is what you can take around the loop and bring back without violating invariance under rephrasing. Now we turn back to the formal heart and make it fully graspable in simple words. We have A equals d phi tilde. When we integrate A along a path, we accumulate phase change. When the path closes into a loop gamma, we accumulate a total phase change around the loop. But because phi tilde is a lift of a circle-valued field, the total change around the closed loop is only meaningful modulo full turns. That is why we wrap it back onto the circle using exp I times that integral. That exponential is not decoration. It is the act of returning the memory to the circle where phi lives. So holonomy is the legitimate circle-valued memory of a loop. Now we can say it in one sentence that even a new listener can keep. Holonomy, h of gamma, is the point on the circle you get when you take the total phase change around gamma and wrap it back onto the circle. And we can also say the strict statement, h of gamma is equals expandel of I d beta of gamma d phi belongs to U1, the unit circle group. Now the triunity integration must be felt, not just stated. So let's make it vivid. Imagine you and I are reading A like a musical score. One listener focuses on cadence, omega. Another focuses on texture, kappa. Another focuses on transport, nu. But all three are reading the same score, A. Holonomy is like the signature at the end of a phrase that tells you whether the score returns to its tonic or returns with a twist. If two phrases have different holonomy, then no matter how you describe them, the score cannot be globally the same. Something in the recomposed A must differ. Therefore, the tri-echo must differ somewhere as a welded whole. This stops a subtle cheat, pretending that different global behavior can happen while all local readouts remain unchanged. Holonomy says, global loop memory constrains local behavior. Now we formalize prediction and falsification in the language level sense. Prediction in this part is grammatical. Holonomy is stable under admissible redescription and depends only on loop class, once loop equivalence is installed. In other words, if you only change the description, gauge, lift, chart, holonomy cannot change. And if two loops are the same, in the sense of later grammar, holonomy is the same. Falsification in this part is also grammatical. If someone shows holonomy changes under permitted equivalences, without the loop crossing an obstruction or leaving D, then the holonomy token is not invariant, meaning the language is inconsistent as stated. So the falsifier is show h gamma changes under allowed moves while staying inside D and not crossing genuine obstructions. That would mean we misunderstood either the allowed equivalences or the construction itself. This is the firewall. It makes holonomy a strict token, not a story. Now, let's connect holonomy to what came just before and what comes next, without teaching the whole arc again. We just came from part 18, where closure produced integers. The loop integral of d phi tilde around the closed loop in D is 2 pi times an integer. That gave winding number. Holonomy now takes that same loop memory and expresses it in the native group form U1. It is the language's way of saying the loop returns with a circle-valued token. And where do we go next? We will soon need to compare loops. We will need to say when two loops count as the same loop for the purpose of invariance. That requires loop equivalence, composition, and deformation rules. That is the coming grammar. How loops compose, how holonomy multiplies, and how invariants depend on loop classes. Holonomy is the token. Next, we will learn how tokens combine. Now, the memory crystal imagery had a powerful emotional core, returning changed, yet carrying an unchanging witness. We can keep that richness, but we must keep it non-teleological and PS0 clean. So let's rewrite that image with strict discipline. Imagine a traveler who returns home with a seal. Not a mystical seal, a wax seal. The traveler can tell many stories about what happened, but stories can change. The wax seal is different. It is a token that can be checked. It either matches the imprint or it does not. Holonomy is that kind of token. It is not the journey. It is not the narrative. It is not an extra object in the world. It is a checkable record inside the language of what the loop returned with. And because it is a token, it can be compared across observers and across descriptions as long as they speak the same grammar. That is the deepest reason holonomy matters. It makes loop memory public without importing new primitives. Now I want to show you how holonomy is the phase memory of a loop in a way that is easy to picture. Take a thin strip of paper. Put a dot on it. Wrap it around your wrist once and bring the dot back to the starting line. If you wrap neatly, the dot returns aligned. If you introduce the twist before wrapping, the dot returns misaligned. The wrist is not the theory, it is the picture. The point is, the loop can return to its start and still carry a twist token that cannot be erased by small deformations unless you undo the twist by crossing an obstruction, by cutting the strip, for example. Holonomy is that twist token, but for phase. And because phase lives on a circle, the token lives on a circle. Now, a subtle point that must be clear in simple language. Holonomy does not require us to know the absolute value of phi tilde. In fact, absolute values are forbidden. Holonomy only uses d phi tilde integrated along a loop and then wrapped back onto the circle. It is gauge clean by construction. That is why it fits perfectly into the pure phi language. Now let's stress the domain honesty again, because this is where people often cheat. Suppose your loop crosses a region where the lift does not exist. Then d phi tilde is not defined there. If you still try to integrate, you are smuggling in a hidden choice, and your holonomy becomes a fiction. Holophase does not allow that. If you want holonomy, you must either stay within the clean domain D, or later you must explicitly type the obstruction, defect, boundary, cut, and use the appropriate grammar. So holonomy is a token of clean loop memory. Now, because we promised examples across scales, let's scatter a few more, but keep them clean. Quantum scale picture, without importing quantum theory primitives as foundations. Think of a wave-like pattern on a ring. You can trace one full lap around the ring. When you return, the pattern must match itself. The matching condition is not a guess, it is forced by closure. The matching phase you return with is a holonomy-like token. Biological scale picture. Think of walking around a circular track while counting heartbeats. You start at the start line and return to it. The number of heartbeats is a tally. It may vary. But the phase of your breathing relative to your steps when you return, that is a cyclical token. Some people return in phase, some return out of phase. That is a holonomy-like idea, a circle-valued memory, not just a count. Civilizational picture. Think of a ritual performed yearly. The count of years is a tally. But what matters for the ritual is the position within the cycle. Spring, summer, autumn, winter. That position is circle valued. It is U1 like. The ritual returns each year to the same phase token. Cosmic picture. A planet completes an orbit. The number of orbits is a tally. But the phase within the orbit, the angle position around the sun, is the circle token. Holonomy is the formal version of phase position after a loop. Again, these are pictures. The mathematics is our actual statement. H of gamma equals exp tie times the loop integral of d phi tilde. Now let's make the formula fully audio-friendly one more time, because the listener must be able to hear it clearly. Holonomy token. H of gamma equals exponential of I times the integral around gamma of d phi tilde. And we can add H of gamma is an element of U1, the set of complex numbers of magnitude 1, the unit circle. Now we need to make clear why U1 is mentioned at all, without turning into a math lecture. U1 is simply the circle of possible phase values. Holonomy lives there because holonomy is phase memory, and phase memory is cyclic. When you add full turns, the circle identifies them as the same point. That is exactly what we need for a gauge-clean token. Now, a careful point. Earlier, we said winding in a clean domain forces integers, and that makes exp I times 2 pi n equal 1. So why do we still care? We care because holonomy is the stable packaging that will remain meaningful as we widen the grammar, without adding new primitives, when loops sense obstructions, when domains have holes, when defects are present, when cuts are declared, when loop classes become non-trivial. Holonomy is the correct token to carry into the richer topological grammar. Winding is one projection of it. Holonomy is the native object. So holonomy is not bigger math. It is better language hygiene. It is how we keep the loop memory in the same alphabet. Now we can seal the carry-forward sentence for this part. Here is what you should carry. Holonomy is the loop's phase memory token, defined by h gamma equal to expect I'm x-spline gamma d pa, living on U1, invariant under gauge, lift, and chart changes, defined only on clean loops in D, and constraining the tri-echo because it constrains A. Now we bridge to the next part naturally. Once we have a token for each loop, the next question is unavoidable. What happens when we change the loop without crossing anything real? If I pull the loop like a rubber band, stretch it, bend it, slide it around, when should holonomy stay the same? If holonomy is truly a topological token, it must depend only on the loop's class, not on its exact shape. So we need the rule of sameness for loops. We need the grammar of when two loops are equivalent. That is where we are going next. Loop class, deformation, composition. But before we step into that, sit for one moment with the image. A loop returns. Reality does not hand you an absolute phase value. That is forbidden. Reality hands you a token that survives all honest redescriptions. That token is holonomy. A traveler returns with a wax seal. A melody returns with a final chord. A woven thread returns with a twist or no twist. A planet returns with a phase angle. A cycle returns with a circle-valued memory. Holonomy is the language's way of making that memory public without inventing new nouns. And now we are ready to learn the next discipline: how loops themselves are compared, how they compose, and how holonomy tokens multiply when loops combine. Because in a language of cycles, the deepest grammar is not just what is a loop, but when are two loops the same. Always, peace be upon you.